Okay, let's begin. So, good afternoon, everyone, again. Welcome to the session on EOS Compute Platform, status and the way forward. I'm Smitesh, the first speaker for you today, and I'll also host and moderate the entire session for you. I'm an innovation management specialist at AGI Foundation. We have a great line of speakers for you today, as you can see, who will talk about the different aspects of the compute platform. And I'll introduce them as and when they come up to the stage to speak. To make it easier, we'll have the questions at the end. We have a small panel discussion at the end, so it will be easier because all the speakers will be on the stage. So hold on to your questions until the end. In terms of what to expect for the next, about 85 to 90 minutes, if we are lucky, less than that. We first begin with me, of course. I'll provide a quick overview of the AGI project, which is what is delivering the EOS Compute Platform. Following that, Giuseppe will present how we approach user engagement in the project, and he'll go into more details about how much impact the project has brought forward. Then we have Christian and Joseph, who will bring the user perspective on this discussion, and Hakan, who will bring a provider perspective with special focus on the high performance computing. Finally, as I mentioned, we'll have a panel discussions with all the speakers, and we'll also have Tiziana joining for that one. So, again, I'm Smitesh, if you forgot my name from 2 minutes earlier, and I work for AGI Foundation. I'm the innovation management specialist, and I am also the innovation manager for the AGI project. So I deal with the aspects of exploitation and innovation management during the project. And that's with that hat on, I'll present to you the overview of the project today. So AGI or AGI Advanced Computing for EOSC, if you want to expand the full form of it, was conceived about 3 years ago in response to the Infra EOS 07 research and innovation action. And the main mission of the project was to implement the EOS Compute Platform, which is what we are talking about today, and through that contribute to the EOS data commons, or what we now refer to as the data spaces. It does this by providing free at point of use solutions with integrated computing, platform services, data spaces, and tools. And the project does this with the aim of empowering researchers from all over the world, from different disciplines, so as to and enable them to collaborate efficiently and effectively in a data and compute intensive environment. So we do this in the project by building on the operational capacity and expertise of the AGI Federation and the results from the previous EOS Hub project. If I want to talk a bit more about the project and its beginnings, the project started in January 2021. It's a 30-month-long project coordinated by AGI Foundation with about 33 partners and 23 linked parties. It has about a budget of more than 12 million, out of which about 8 million is contributed by the EC. And of course, it will, if you count from January 2021, the 30 months ends in June 2023. It has about 1,400 project months, with almost half of it, which is 49%, dedicated to virtual access. And through this, we are going to provide 82 million CPU hours, 250,000 GPU hours, and about 20 petabytes of hosting and exploiting research data. No doubt we'll see a lot of representations of EOSC in the coming days, but the one we are in this slide we have included is from the Solutions for Sustainable EOS, which was a report by the EOS Sustainability Working Group, which is a very simpler representation of the EOS architecture with only the basic elements of EOS core, federated data, and EOS Exchange in that. And what we have done is we have tried to visualize how AGI fits into this entire picture. So we have about 5 objectives, which is primarily being delivered through the project. Chief among which is delivering the EOS Compute Platform and integrating the EOS Compute Platform with the EOS portal and the EOS core. Through that, we also want to try to contribute to the global open science cloud and expand the demand side, so expand the user base of the EOS across different sectors and disciplines. So in the earlier slides, I mentioned that AGI is sort of builds on the capacity of the expertise and of the AGI Federation. So this slides helps us dive down into that aspect a bit. So if you're unaware, AGI Federation consists of 27 members. You can see the members on the right with the blue ones being the full participants and the orange ones being the associated participants. Sorry, the noise from the other room is sort of distracting me. EGI, it started in 2010, and we started with serving computing and storage. Eventually, then we added the cloud computing to our services, and now finally with EGI, we are delivering HPC. So on the left, you see all the high throughput compute sites, which is the first image on your left, and then we have all these are the cloud compute sites. And these are the 4 pilot HPC slides, which Hakan will talk about a bit in detail later on. Through this, we deliver more than 5.2 billion CPU hours a year through HTC, 43 million CPU hours through cloud, and we serve over 75,000 users. Since we're talking about the EOSC Compute Platform, we zoom in more on the computing aspects and restrict the same images that we saw in the earlier slides to EGIAs. So we have, as I mentioned, we have 27 cloud providers, out of which 15 are funded in the project, and then they support about 23 use cases. Out of the 200 HTC providers, 1 is funded through virtual access in the project, but others through their national funding, they support the 58 use cases. And then, as I mentioned, there are 4 pilot HPC centers here. So what is the EOS Compute Platform, right? So this is simple, still a lot of layers in it, architecture of the EOS Compute Platform. So at the bottom, you see the federated resource providers. These are the infrastructure as a service cloud providers, the HTC and the HPC, which they deliver a hybrid infrastructure for hosting research applications and data. So we have these 3 different types of resource providers which sit at the bottom of the architecture. On top of it is the Compute and Data Federation, which has softwares and technology which allows the users to manage their workload and execute the workloads through these federated resource providers. And the data federation, which you see on the right, it supports the exposure of deliverable data sets and staging of the data in the EOS Compute Platform. On the top of that is the platform layer, which is generic platform services which are built on top of these resources which can be then taken by the individual use cases or research communities to build their own thematic services on top of it. So some examples are the interactive notebooks or the Jupyter notebooks that we have come to know them as, the deep platform for AI and ML. There are some scalable data, big data tools, and platform as a service orchestration tools. And on the left, you see some core services, which is AAI or check-in, which allows for portability of identity, configuration database, accounting and monitoring. This form the core services which enable all the things on the right to work together easily, seamlessly, and helps us account and monitor this entire aspect properly. And as I mentioned, thematic services at the top are built on the top by combining using the platforms and using the platform services and using the data brought in by the research communities tailored to their own domain. So these data spaces and tools focus on the data exploitation that they have, and each thematic service has tools adapted to the disciplines that they target, right, under disparate arbitrary architecture. So that's basically the structure of the EOS Compute Platform. I will not go into too much detail with these slides because Giuseppe, when he talks about user engagement, he'll go into more details about it. But to explain that we have 2 channels from which the users come to the EOS Compute Platform. On the left is the EOS portal, because all the services have been onboarded to EOS Marketplace. So we get single users and smaller groups from the EOS portal. We do have AGI's open calls. You can find some flyers at the back near the entrance, through which we also support projects and communities and research infrastructures. And then depending on the requirements and what they are doing, from which discipline they are, how much resources they need, there are different business models which Giuseppe will talk about that they get used to it, that they get access to these services through EOS Compute Platform. So who are these users? So if we look at the users that are supported by the AGI projects, on the left we have the 15 thematic services which are part of the consortium, and they are color coded depending on which sector they come from. So I don't know if you can read at the back, but the yellow ones are from the energy and physical sciences, the green ones from climate research, the orange or dark brown ones from health and medicine, the gray one is structural biology, the humanities is represented by purple, and then the blue ones are the environmental sciences. And on the right you see a sort of a graphic telling you about the use cases which we have received through the call through the open calls. A major chunk, about more than 1/3 of it, comes from environmental science, followed by engineering and technology and life sciences. Then we have smaller numbers from different, like humanities, physics and astrophysics and so on. And if we look at what we have achieved in the past 20 to 22 months, I'm not going to too much detail again because Giuseppe will talk about impact, but we have integrated more than 35 services from the consortium on the EOS platform. We have 8 services from external providers, which are of course supported by the AGI services. We've integrated 15 thematic services with the AGI services, and finally we are serving more than 77,000 users, 76,000 of them who are using the thematic services, and about 1,300 have benefited from the platform and infrastructure services. So next up we have Giuseppe. Well, he's going to talk about user engagement and impact. He's our community support team lead. So if you want to talk about community engagement and everything during the conference, you can reach out to him. Another fun fact, if you want to talk about, I forgot the name of the dish already. Arancino. Right. That's a special dish from the Catania region. If you want to try it or want to know how to cook it, talk about it at dinner with Giuseppe.
Thank you. Okay, so let's continue this discussion. I will focus a bit more on the user engagement aspect. Okay, so as was introduced before, to engage with our customer, we set up these 2 different channels. One is via the EOSC portal. This marketplace is a sort of yellow pages where the user can discover services that may use to support a specific research activities. So all the thematic services integrated, supported by AGI are published in this marketplace. So in principle, you can already discover and request access. Most of these services are open, and there are also some capacity allocated, and some other require approval from the service provider. So you submit a request to get access to one of these services, and if the service provider grant you access, you can start to use it. So this is the first channel. This is mainly to target community long tail of science user, so that basically need to do some research activities. They discover some solution, easy solution, and start to integrate them. The second channel is has been defined to target a more complex use case. We are talking here about international project, multinational communities or research infrastructure, because what they need to do in practice is not only to use one of the services published in EOSC, but most of the time combine or integrate multiple services. So what we have done to target this kind of request is to open this open call. So the idea is to use this call to select new additional communities and provide not only the capacity but also the technical support. This is the most advanced, the most the biggest benefit of this open core, because we not only provide the capacity and the services, but also the technical support. So we provide the expertise to integrate them in your domain-specific use case. So the call was officially launched in 2021. It's completely open. So we have a cutoff date every 2 months. So which means that after 2 months we analyze what has been received, and we try to map this request into a set of capacity, set of services, and the expertise that can support you. To support this business model, we have different funding mechanisms here. So for sure, we start to reuse as much as possible local fundings from the funding agency, if possible, of course. So for example, if we receive a request from a project, H2020 project, which want to support, which request the cloud capacity for biologists, for example, this is just an example, what we try to do is to identify in our federation the partner that are tasked or missioned to support this kind of community. They receive, if they receive national fundings for supporting this community, we try to do this matchmaking. If this is not working, okay, we will use the fundings from the European Commission, which are available through the virtual access mechanism. And there is also possibility to use a pay-per-use model, because some projects, for example, have their own budget that can be used to request for additional capacity. So this is the channel and the business model, the funding mechanism that we are trying to promote for engaging with our customer and trying to increase the user base. So in principle, so as a summary, we have 2 channels, as I mentioned before, the open call and the EOSC portal marketplace, from where the user can submit a request. And once we receive a request, what we have done is to set up this engagement pipeline. So we start from the assessment of the requirement, as I mentioned before. If necessary, we try to contact the customer to clarify a bit this requirement. If this assessment is successful, we allocate the technical expert, we allocate the capacity, we launch a competence center, which is the sort of mini project to support the integration plan of the customer. And once the co-design and the results are completed, we support the onboarding of a new platform in EOSC. This is the most intensive part of this engagement pipeline, because this requires a lot of discussion, clarification with the principal investigator, and also to allocate the proper resources, services, and resources. So the most important aspect of this pipeline are the concept of the shepherd. This is the technical expert that we assign for each of the use case, a community use case that we want to support. This is the technical expert responsible to liaise with the customer, but also with the service and the resource provider of the federation, to monitor the progress of the integration, and also to report a possible problem and propose solution to solve the problem. And the concept of competence center. So we launched this competence center, which are this network of experts from different areas, from the community, from the federation, to facilitate and work together with this in these collaboration activities. The activity done by AGI for allocating the capacity and the services is structured in this diagram. So basically, starting from the requirement received from the community, as a broker, we try to identify the provider of the federation suitable for supporting the community. And if this matchmaking process is successful, what we do is to create a service level agreement with the customer. So this is a gentleman agreement we use to describe the level of services, the solution offered for supporting research activities. And at the same time, we use operation level agreement with the service provider, okay? Because we want to make sure that the customer receive the proper services according to the service target, if there is the proper level of support, etc., etc. We also monitor the provisioning of the services. So we check and produce on regular basis service performance report every 6 months. And every year we organize a customer interview with the customer because we want to get the feedback to improve the quality of services, performance of our solution, etc. So this is the workflow that we adopt every time that we receive a request, and we try to match make the request with the resources and the provider of the federation. So far, we received more than 113 service orders through the marketplace, and we supported them, and 42 different use case applications from the open call. Some additional information about some statistics about the application received. I forgot to mention that when we launched the open call, we started a marketing campaign. So we tried to promote this open call because we want to receive requests from different projects, multidisciplinary community, etc. And this is why after 10 rounds of selection, we collected 42 different use cases from different scientific domains, not only from life science community, but social science, engineering and technology, and many, many others. These requests coming, of course, most from the long tail of science, but not only, because we managed to reach a different H2020 project, and also SME, because we are also serving the business pilot from the EOSC Future project. So we are supporting also this kind of use case. And we have also some research infrastructure that approached us. So as a summary, the project, the engagement plan, the engagement activity done by the project was quite successful in terms of new community that we reached. We have 42 different applications supported, received, and 38 applications supported. 3 new platforms are now onboarded in EOSC. So thanks to these engagement pipelines that I presented before, new solutions are now available in EOSC and are contributing to the EOSC Exchange. You see here that we are contributing in preparation of, so the project was sponsored 22 different scientific applications. We have one use case that was published in the EOSC Future magazine, and we managed to establish contact and synergy with the Reliance and the EOSC Future. AGI is not only supporting the Digital Innovation Hub of EOSC, but also the science project. So we are offering the capacity for supporting the integration of this use case with the core services. Now, in the next part of the presentation, we are inviting 2 different communities that will be selected via the open call to produce report about their experience. So,
well, so if you did talk with Giuseppe in the evening and had too many arancinos, the next person is the perfect person to talk to because he is a mid-distance speed runner. So if you want to lose all the extra fat that you have gained through eating that, please talk to Christian, who is a high-level research engineer working on climate data distribution infrastructures with special focus on big data issues. He's from Surfax, and I'll let him continue with his presentation.
So thank you very, very much, and good afternoon to all. When I saw the open call by EGIS, I thought it was a really good opportunity to put into practice and also do the implementation of one idea I had for climate data, because I've been involved with end users of climate data, and I know that it's not always obvious to use the data we have. So the idea is to produce data that is more actionable, so closer to the needs of the users. So right now the climate data distribution is using the Earth System Grid Federation. So it's federation of data nodes located around the world. And those data nodes, the interface is not really straightforward to use for non-expert users, especially those who are in other scientific domains. And another problem is that the available variables are really the output of climate models, climate simulations. So this is great, but it's really standard variables like temperature, humidity, and precipitation, and so on. So this can be useful in many applications, but not most of the applications need more than that. And so they need the users need to post-process this data, and it's not really obvious with the data volumes and how the data is distributed in those data nodes. Also, the frequencies are daily, monthly, and the end users, for example, if you work with climate data, daily data is interesting, but you do need to compute statistics, so you need to access a lot of data. So it's really not obvious for end users to directly use all this data. So there's a gap between the user needs and available data for climate. It's not there are no gaps for all all the users, but most of the users will find problems in using those climate data simulations. For example, if you want to assess climate change anomalies, then you need to compute the anomalies between the future climate and the current climate, and you need to do that for several simulations. You may want to evaluate climate extremes, so that to do that you really need to post-process a lot of data. And for the climate change impacts, it's even more difficult because you need to process and combine different variables together. I can show you some example of questions that needs to be answered for different kind of users. For example, they could ask, would there be more droughts in northeast Spain in the future compared to now? How likely will have landslides occurring in the valleys? Or which region in Europe will see the greatest change in heat wave intensity and occurrence? All those questions are very interesting and very useful for our society, but it's there's a gap between what's provided in the climate data infrastructure and the input data you need to answer those questions. So the idea is to post-process the data and to create a database of climate indices. And what are climate indices? So climate index is derived from basic climate variables such as temperature, humidity, precipitation, wind, or other variables. And what we do when we compute a climate index is that we calculate things such as those two examples here. For example, warm days. So this is a standard climate index that is defined within the international community. So days with mean temperature greater than the 90th percentile of the mean temperature, or the number of summer days. And so those are standardized by several standardization authorities. So this is an example plot here on the right hand side. So so those are other climate indices that can be also calculated. Those are specific for summer extremes. So we have a list here that is presented on the website and showing the European state of the climate for 2021. So those are very interesting things to pre-calculate for the users. So we have a tool that has been developed we have developed that at Surfax, but within the context of the H2020 project called EasyNess 3. And this tool is a Python's open source software, and this can be used to calculate commit indices. So it's very simple and flexible with an API, fast processing. But still, even if we have this tool, it's not easy to use this tool and to post-process data that is on ESGF. Why is it difficult? Because you need to process really a sufficient number of climate projections to calculate those climate indices. Why you need to do that? Because you need to assess the uncertainties. You may want to explore several greenhouse gas emission scenarios, and it's very difficult to download all data for the user. So the idea in this use case is to pre-generate the 50 standard climate indices on all the CMIP6 simulations and extend that in the future to ERA 5, Cordex, and CMIP 5. So I have set up this use case to process the core set of simulations from CMIP 6. So all climate models and greenhouse gas scenarios and ensemble members. So this is the reference period we have chosen. So it's 1981-2010. And then we have the scenario data on the right-hand side from 2014 to 2100. And so the computations are done using this infrastructure. So it's using the INES data space. And it was very convenient to have all input data at the same location and be able to run those calculations and generate the database. So it's running on the AGI ACE resources. We have done the development using the Jupyter Notebook interface, and it's still in production now. So it's running using a Python script execution from this notebook development. So the timeline, we had some delays in the initial planning. So there was some delay in starting the action. It was really during the summer. I've had really good and prompt support from the team, and several technical adjustments have been done. It was complex to develop the script because of all the different input data needed, and also combination of variables. And in September, I was extremely busy, so it was a bit on hold, but now it's in production. So it's still not optimized for the processing, but now it's getting good shape to generate this huge database. So the future action is to validate the calculations, and the question is to decide where to store this database to make it accessible to all the users. Also open, of course, and make it accessible to the EOSC Climate for Impact platform. And it will also be used to support the Horizon Europe Mentor-Twin project. And we need also to disseminate that this database is available. So those extensions I've been talking about also will be done after that. So I'm finished.
Yeah, thank you. Well, after all that climate change talk, if you are worried about climate change, maybe you want to talk to our next speaker, Giuseppe, who is very proficient in sailing. So in case you are in trouble, you can always sail away. So Giuseppe is a member of the Saki Parallel and Distributed Systems Laboratory of the Hungarian Academy, and he's been very active in intergovernmental and European Union research and development projects. I'll let him talk about the NENIAS project.
Thank you. Okay, so in the next presentation, I'll try to summarize what we managed to reach with the AGIS resources in our project. But in this situation, I'm trying to focus on the story instead of the final results. You will see why. So this NENIAS project is a 3-year project. It finished by the end of October, 2 weeks ago, It had 21 partners. We are just writing the final project report from 10 countries, but what we are proud of is that we managed to onboard 14 EOSC services. These services are a kind of thematic services. In the project, we covered 3 different scientific areas. One is the atmospheric environment, underwater environment, and also space science. And we were also focusing on addressing community-specific needs. Also, we onboarded the services and tried to explore different business opportunities. And before we gained access to the AGIS resources, most of our services were deployed at Gar. Gar is an Italian cloud provider, where we got Openstack, and also we got private Kubernetes clusters, which was mainly managed by us and by Gar. And the advantage was that our service providers, mostly coming outside the compute science, were introduced to contemporary cloud technologies in a controlled environment. So, but the problem was that these services was tightly coupled to a single infrastructure, and there was really limited resources. For example, Gar didn't provide any GPU resources for us, so we had to find some resources where we have some access to GPUs. And then we submitted our application, and it was accepted by AGIES at the beginning of this year. And Cesnet was selected to host the resources. And what we got is that we got some OpenStack cloud resources with GPUs. And also we received some shared Kubernetes cluster, which was managed by Cesnet. So how we utilize these resources? First, we deployed Horovod. Horovod is a distributed machine learning environment for native learning workloads. Yeah, and this was deployed on the OpenStack, and we managed to utilize GPU resources. And we did this. We managed to significantly improve the performance of the machine learning calculations. And then we did the same with the Spark machine learning environments, but we deployed it on the managed Kubernetes cluster, again with GPU access, of course. And then we allowed a series of service providers, so the service providers from the project, to become starting to develop some mechanism to be compatible with the managed Kubernetes offering, what we got from Cesnet. In this we followed a new model, and Neanias was one of the first projects to validate it. I will soon tell you about the model, what I mean on. We tried to learn the differences, the restrictions, and the grains, and try to prepare for moving around the AGI members. I mean the resources. And the model what we followed is that bring your own resources. And why did we follow it? Because the project decided that no matter where the thematic EOS service is deployed, it is very hard to serve all Europe from one single service provider. So if the other aspect is that whenever a service scales with its inputs, so huge amount of computation are submitted, which for example requires tens or hundreds of gigabytes of memory or terabytes of storage space, then it is very hard to handle it. And we finally decided to somehow support for the customers to bring their own resources under the services which we are hosting. So what we tested in Neanias during this year is that we have, for example, we have a service which was deployed on a Kubernetes cluster in Neanias, especially in Gar. And let's assume that these jobs are submitted on the same cluster normally. These jobs should be considered as the heavy, let's say, scientific workload or computation. And now what we have done is that we allowed the users to pass, for example, Kubernetes config files for adding an external cluster along with the request for computation. By this, our services are able to submit jobs, not only the local clusters, but also to remote Kubernetes clusters as well. And in this case, the jobs are also submitted to these external, or let's call them alien clusters. And what we had to do is to somehow maintaining the log aggregation, accounting, and so on, and maintaining also the UI feedbacks as well. So there are some advantages and disadvantages of this, let's say, this model. What we try to follow is that in this situation, the burden is on the service consumer to allocate more resources for her computation, and in some situation it may happen that in the minimalistic case, the thematic service should only host its own web interface and nothing more. So it's more difficult, of course, to control the jobs and control the execution. And this model was successfully validated, but not yet in production at the moment. For open source software it was easy, but it was more complicated for non-open source one. And we had some issues which were addressed. Cesnet was very helpful in resolving these issues. A big thanks to them. For example, they wrote code to resolve the technology stack differences. For example, log aggregation was done in a different way in the Gar Kubernetes clusters. They provided special storage provided that allowed to mount web.d resources. For example, we used simply rclone, and we got root privileges on the Gar Kubernetes cluster, what we didn't have on the Cesnet. And they introduce also rancher projects to allow privacy between our service providers, because from Cesnet we got a huge big Kubernetes cluster and all the services should be executing there, and that was not so comfortable for us. So finally, what Neanias gained from this story is that we now better prepared to move our services around the clouds between for example, AGI member clouds or EOS clouds. And our machine learning workloads, of course, has been successfully executing there and are now got some performance advantage, of course, because of the GPUs. And what we, let's say, somehow, these are our suggestions summarized. So, for example, AGI could work on the authorization integration between AGI check-in and both the Openstack and the managed Kubernetes clusters, because this was somehow a burden for us, and Cesnet managed to solve it with some workarounds. And this is dissemination, for example, of these managed Kubernetes clusters, because these are the let's say the future. This is what we think, and strong technology compatibility across AGI members, because to assist the services to move around and to migrate from one cloud or one set of resources to another. So that was the end of the story in Neanias. Thank you.
Thank you, Joseph. Well, if you're looking for some entertainment after all these talks, you can always talk to our next speaker, who is a music addict and an avid dancer. He also does a lot of bass playing. He's Hakan. He also has a fantastic Twitter account, so you should check it out before Twitter goes downhill. So ask him about his Twitter account later on. He is a senior researcher at TÜBİTAK, the Turkish academic network and information center, where he focuses work on high performance computing, parallel computing, and numerical computation. So here's Hakan talking on HPC services.
Hello everyone, so this is the last presentation. I will try to make it quick. So what we were doing in the HPC integration, first of all, so we want to make sure that HPC is a first class citizen in cloud computation. So we need to make sure that everyone can access HPC services with their own accounts and run their own applications and carry their data anywhere in this federation. And we can make sure that HPC systems can provide the same insight we get from the cloud sites. So we had 4 pilots in the work package. IFIN did some other tests. They implemented HPC as a service on cloud. CERN did some benchmarks. CMCC did some real-world execution on containers, which we directly backed. And United Kingdom Atomic Energy Authority moved some of their workloads to HPC, which we partially exposed to, but I'm not very fluent on that one either. So, by saying who we are. As TÜBİTAK, we are the National Research Network. We provide the whole academic network to universities and make sure that it is connected to JEON and other academic networks of the world. Also make sure that they have internet so they can read my Twitter. Also, we are a national HPC center for a long time. We have 25,000 cores, some GPUs, a bit of storage. We have a lot of registered users, and 350, 400 of them is active at any given time. We are participating in AGI. We have a full production Fed Cloud site. Also, we have running an HPC pilot. Also, we were the semi-official site for SSH IDC testbed, and also we provided feedback. Lastly, we are in this ecosystem for a very long time, since the grid days. So, as the 7.3, we have came up with 3 possible solutions. First one is HPC as a service, which is running an HPC infrastructure direct on top of cloud, which I am not very fluent on because we didn't do that. The second one is SSH plus Federated Identity, which we did a lot. And some HTC middleware gateway, so you use the same software to somehow talk with both HPC and cloud sites. We are also partially exposed to that one. So the first one is, I am not very fluent, but I will try to explain. If you need any more details, I can direct you to the people who did that. On Openstack, you are running VMs and you are setting up special pass-through parameters for InfiniBand and GPU, so you can have bare metal-like access to the state hardware, and you get somehow almost the same performance, but I don't have the numbers. They put a Swarm head node like a real HPC system, and everything is monitored by AC3, so if you are running up to capacity, if something starts slowing down, new nodes are automatically spawned and the cluster is grown or shrunk according to the workload. So what we did with SSH plus Federated Identity, we used SSH OIDC add-on on a real HPC cluster. It was a very small but real HPC cluster. So you SSH to that cluster with your AGI username, and it magically logs you in. It creates a persistent user for you. So when you come back, your user will be there, and all your VO memberships will be mapped to Unix groups. So if there are any other users which have the same VO memberships with you, you can collaborate on that like you are running on the grid or the cloud system. So you can collaborate, you can isolate your workloads, you can run real HPC workloads as normal because it runs Slurm. We have made sure that Apptainer and Singularity was running on our cluster, so NS project was able to run their workload on the small cluster and get real results. We also provided some feedback to the SSH IDC guys, so they were very responsive in implementing what we need or addressing the problems or concerns we had. So this is the architecture of the NSHPC pilots. They have a 1 or 2 node standard OpenStack cloud implementation, which is always on, which is running Jupyter notebooks. And when you want something demanding from that notebooks, automatically a job is submitted to the HPC cluster. And when the results came, it is reflected back automatically to the Jupyter Hub notebook. I don't know the technical details of it because they have implemented the Jupyter part, but if you need help or details, I can redirect you to the person. But they didn't report any problems, and they said it is working very well, so we consider it as a success. So this is provided by Cesca. This is how their implementation has provided some HPC resources over the months. So they have provided around 1 million CPU hours with their HPC pilot. So we didn't enable accounting on our pilot, but as Slurm keeps very detailed accounting, it is very possible to get AGI production accounting and more if you want. So as a result, there is an idea floating like which we call AGI Accelerated Cloud. This is some federated cloud sites with some HPC components baked in. So if you need HPC-like performance for some of your workloads, you can use some of these sites. Your normal workload will run on cloud, but you can submit jobs to the HPC accelerator part. So you can have on-demand HPC and always on cloud in a single site. We are one of the providers, so our small pilot is open to everyone. If you need, you can use it. So what can be done as the future? These are my ideas. These are free-floating ideas. Feel free to shut them down or grow them. First one is libraries for ease of access, because everybody is developing some software or using something which have access to, and having some library which they can supplant to work with HPC in an easier way is always welcome, because you need to know how to create Slurm jobs, you need to how to monitor them, how to submit them. There's a lot of parameters to know, and something automating this will be very welcome. Everything is REST these days, and Slurm also has a REST endpoint if you want to. It is optional, and maybe another library for REST part of Slurm will allow anyone to submit jobs from other sites to an AGI accelerated site via HPC to HPC via REST. So they can put their files there and say that I have a job like that, can you please run them? It is a bit tricky because we need to do user mapping and such, but it is, I think, doable. Also, if you fuse the first two ideas, you came up with a crossbar for global access, which is again inter-site data transfer and job submission helpers, which will allow anyone with access to the accelerated site to work in a more flexible manner. If you want to know what we have done, what we have achieved, and what we recommend, you can go there and download the HPC Integration Handbook we have written as a deliverable. So that's all.
Thank you, Hakan. That has been how what the status of EOSC Compute Platform is now. With this slide, we wanted to present what our vision for the collaborative compute continuum is for the future. So on one end, you have these national and international compute infrastructures, like the EGI one, which we prominently talked about in this one, but Euro HPC and from EOS Future, who have national and institutional priorities related to science and computing that they need to take care of. While on the other hand, you have the research infrastructures, projects, and researchers, the users basically coming from diverse disciplines, which are working on different things, delivering impact and outcomes. And through this diligent matchmaking support provided by Shepherds and Competence Center, something that Giuseppe talked about a bit, and technical compatibility provided through this layer with AAI, with Data Hub and AppDB. So that is the identity portability, data portability, and application portability. We want to create a seamless, collaborative computing continuum. And this whole collaboration, which something Giuseppe mentioned as well, is governed by the service level agreements and the operational level agreements, which ensures the reliability and availability of these services and resources. As a final next step, I would like to invite all the speakers and Tiziana onto the stage to take a stage so we can have some discussion. Since I'm not introduced Tiziana to you, I'll do that now. So if you are unaware, she is the director of EGI, which basically ends the discussion there. But if you want to, because I cannot make too much fun of her, my job relates to that aspect. But you can talk about how to raise twins with her, or if you are adventurous, how to skate in the canals of Amsterdam during winter. So that's an interesting aspect which you can talk to her. I would like to invite Tiziana, Christian, Joseph, and Hakan to join me on the stage for the discussion. Thank you. So we begin while they take the stage. What we'll do is I have a couple of questions prepared for them just to make their life easier and make them feel comfortable. Then you guys take over and make their life uncomfortable by asking difficult questions. So we begin on a simple note and talk about a bit more and expand on the experience that you guys have had with the EGIA's project and developing this EOS Compute Platform. Maybe we start with you, Tiziana, to talk about your experience and how you have perceived this, and then we can go to the providers and the use cases to talk about how their experience has been.
Yeah,
you can also use the mic.
No, this is working. Yeah. So thanks. And when Smitesh is the convener, it's always a bit frightening because you never know what's going to happen. But yes, so this project, I can't say anything very much about the experience because I'm not a user nor a provider, but I like to remark a bit the vision and perhaps what I've been missing in this session, in these presentations, which we may cover a bit more in detail during our panel. The idea of this continuum, I don't know if you can go back to the slide, is that this is a collaborative effort. First, brings heterogeneous facilities for computing together. And at European level, of course, we have major players there. But also the research infrastructures and scientific communities are integrally part of this challenge. And they bring scientific software and the research data as part of this continuum. So the vision that created this project, and perhaps is still an open vision in terms of implementation, is that computing will integrally come together with research data and the software, and that will create the environments which are facilitating science in the end. So we see in the European Open Science Cloud this to be still a challenge because of the distributed nature of data and the problem of bringing research data next to computing, or vice versa, depending on the point of view, computing to the data. So this vision is still partially incomplete, and I believe the work that Hakan presented is tremendous groundbreaking work to demonstrate how, if we have a compatible access policies, HPC, HTC, and cloud can be integrally delivered to science. But the part which perhaps we can debate, this is my topic, is how the computing continuum can come together with data. And I would be, for example, interested to know in Christian's experiment how the modeling data was processed in a scalable manner. From a AGI perspective, and I think from a EOS perspective, is still a challenge how research data and all the necessary assets that are necessary for science come together in a scalable manner. So, yeah, this is my initial point for the panel.
Yeah. We maybe it's easier we go next to Christian so that he can respond to that. Maybe easier if you use the mic still.
Yeah, this is okay.
I would say that the experience as a user with this use case was really that it was really transparent for me. It was really a Jupyter lab I'm used to use anywhere. So I was using those resources with really HPC resources behind, but with nothing. Really everything seamless. So even the login with the check-in with my login was very fast, and I could access directly the Jupyter Lab, and all the data was prepared for my use case and already available in the Jupyter Lab interface. So it was really seamless. It was check-in was logging in was really easy. I could run my job and then into production. I didn't have to monitor really that it was running. So even the development part with access to the notebooks was really useful to really structure my workflow properly. So what I retained from this experience is that it was, from the user point of view, it was really easy to use, and I didn't have to go into the technical aspects or I didn't have to really modify my workflow according to the technologies behind or the infrastructure behind. It was really transparent to me.
Okay.
So
Joseph, was your experience the same, or did you have a differing experience?
We had experience with the OpenStack and Kubernetes clusters provided by Cesnet.
Yep.
Do you want me to summarize it?
Yeah, well, how was your experience with working with AGI's resources and overall?
So we gained access to, for example, OpenStack resources with GPUs as well. So we managed to somehow make our machine learning related services more competitive with using these GPU services, with these GPU resources. So that was a very positive experience, and also that when we gained access to the Kubernetes cluster with the GPU resources as well, we had to somehow make our services to move the jobs, for example, to a remote cluster. And during this cooperation with Cesnet, we gained a lot of know-how how to work on this. And there was quite a few technical difficulties which we had to solve. And it was also very positive that we collected lots of experiences in this. And finally, we in this as a result of this work, now we consider our services as a kind of moving ones, because in this case the services may utilize remote clusters, remote resources. So that's what we were very happy with.
Hakan, if you want to talk about your experience with working with the use cases from your side.
Actually, I will talk about two perspectives, one working with users and one supporting them technically. Actually, all the use cases we are working with are very easy to support. So the software and the hardware has evolved a lot in the last 2 decades, and everything is much more easier to manage, much more easier to administer, and much more easier to support. So we are having much less headaches, so the users are just working, and after the initial setup we only get questions for fine-tuning or just more resources, so I think they are happy. Other than that, we don't actually, except day-to-day operations, we are not putting out any fires or anything else. Everything has evolved and everything is much smoother now. This is what I can say as a provider.
Good, thank you. Considering the time, I would like to also open the floor to the audience if anybody has questions. If not, we stay with the panel. Oh, wow. Yeah.
I wanted to ask a question to Giuseppe, but maybe it's also for Tiziana, I don't know. Because when you show us the diagram on the EOS Compute Platform, there was a part regarding federated data transfer and management and transfer, and I wanted to ask what are if you could tell us more about this for the future. But then Tiziana said it's still unclear. And I'm telling this because one of the services that is offered in the EOS platform, in the EOS Marketplace, is the AGI Data Hub. And we are considering it in our field in research as the federated solution for data management. And I don't know if this is going to be the one that is going to be recommended, or are you going to use it for this? And I would like to know a bit more.
Giuseppe wants.
So we have, yes, different communities that are already using this solution. Of course, depending by the requirement, we can discuss if there are other opportunities for you to use other solutions offered by the portfolio, available in the portfolio. So,
perhaps I like to clarify my statement. And also where it comes from, because the national infrastructures that participate in the AGI Federation are very heterogeneous, especially the hardware fabric. And the user communities are also very diverse in terms of data-intensive computing, so they may have large amounts of small files or complex data or big data problems in terms of volume. What we find out is that one solution when it comes to big science and big data is typically not sufficient or not addressing technically all the specifications that may come from the users. So the Data Hub is a service which can be incarnated with different technical solutions, and the same technical solutions may not work for every scientific community. In this sense, European scale or international scale data sharing and scalable processing is still regarded as a research topic in AGI, so we have production services. But this is still an area of large R&D, and key communities which are fully and integrally participating in the AGI Federation with their data centers, which are tackling the coming challenges for the 10 years to come, which means 10 times the research data they are processing today, need profound revisions in their data management model. So we foresee this will surely drive the AGI infrastructure strongly in the coming 10 years. And when I say big science, I mean communities at the scale of high luminosity, LHC, or SKA, or other radio astronomy experiments, which have extreme processing challenges in all stages of the data lifecycle. But the service will continue, of course. So there is a pipeline of innovation that brings proven solutions back into AGI, and through AGI also to this EOSC Compute Platform.
Thank you. Any other questions from the audience? If not, then we, in short, what are the biggest challenges or improvements that we can think of for the future for the EOS Compute Platform? From your perspective, from your experience? Somebody wants to start? Since you have the mic, you get the pleasure.
So, as a provider, I see the biggest technical problem is the moving of data around between sites, between systems, because there was a tendency to work with smaller input files, and they were able to move around faster. But since machine learning and artificial intelligence is getting more and more into the numerical algorithms and other simulation stuff, we need to carry around big models or training data to be able to reproduce the research, and moving this in time in a quick manner will be a burden. Other than that, we are going to need more GPUs, and finding them is a bit harder still. So power management, because of GPUs and moving the data, is the biggest challenges I can see as a provider or a system administrator.
Okay. Thank you. Tiziana?
Well, I think we have discussed about distributed data management, and Hakan, you brought up some very concrete examples, so I think, yeah.
You agree with, are we all going to agree with Hakan? That's an easy way out, right? Right now.
Yeah, I would go into the same direction, meaning, for example, in the use case I've been doing, I'm creating a large database that can be used by external users, so there's a need for be able to reference that easily, and also to share it and to external users. So once we have done the computing, then there's the question on how to be have this data sustainable and accessible for a long time, and also properly referenced. So, for example, of course, PIDs. But it's all of this is related to FAIR that we also talked about, and so I think we must not forget this last step after computing, how to ease access to this to the products we are doing, also the database we are creating, so that it can be really used by the largest amount of users.
We are talking about handling huge databases and moving data and so on. So what about moving the services themselves to the data? Sometimes it is more efficient than moving the data. Related to this is somehow which Neanias started to work on in some aspects. That is something which we think that can be valuable in the future. Also, what would be good in the future is that what I already mentioned in my slides, that, for example, supporting the group authorization by the AGI check-in towards the Kubernetes clusters and Openstack clouds could be really beneficial, because that was one of the biggest burden we faced with when we tried to move those services to the Cesnet environment. So that would be really good. And if AGI check-in could manage groups and also propagate these rules towards Kubernetes clusters and OpenStack clouds, that would be really fine. So that is something which we could, let's say, suggest for further improvements. Thank you.
Okay. Any final comments or thoughts?
Quick thing I didn't mention much is that I was really pleased with the support I had, because we had a meeting to launch the use case, and then after that I had really fast support from the team, and I really felt supported. As soon as I needed something, I could ask, and then could have the answers quite rapidly. So I think it's quite important also to have the success in the use cases, and also the use of the computing platform.
Tiziana, final word.
Well, perhaps picking up on this topic, which hasn't been discussed too much in this session, but perhaps is something for coffee breaks and other sessions. The problem of enabling user communities is quite relevant, because we have national expertise or community level expertise, but we don't have a structure to bring this expertise to solve specific problems of scientific communities. And it's my personal opinion that this aspect has been overlooked so far in the EOSC implementation strategy. We see this function to be as important as technical solutions, and it's often the Cinderella in programs. But without this, we cannot really have successful exploitation. So my hope, perhaps as concluding remark, is that technical support, connecting experts, and here I see Jonathan in the audience, but bringing research infrastructure experts which had the knowledge of software and data, and infrastructure experts nationally together would be really very powerful and major achievement of EOSC.
Well, thank you. If there's nothing else, I would like to close the session. Big round of applause for our panel and all our speakers. Thank you everyone for joining us. My final gift to you is 12 minutes you didn't know you had, because we're ending early. So think about the EOSC Compute Platform and find all of us if you want to talk about it further or about other things that I mentioned. Yeah, thank you, and have a nice evening and a good conference ahead.
Thank you, Smitesh. Thanks everyone.